right, thank you so much. My name is Melody. I lead the team at Observable, and so happy you're all here for our first virtual meetup, our first of many. I've worked in software development all of my career, from startups to enterprises, and I don't know, about 5 years ago, I started working on tools to make developers productive, and I was hooked. Like, this is the thing that I want to work on. And I believe visualization is at the center of what can help us be better software developers, how we do our work and how we collaborate with each other. So I'm going to present in the next 15 minutes or so a little bit, hopefully, of inspiration, some examples from our community. You're going to see titles on the examples that you can just go to Observable and fork them and start playing around with them. And I hope that you come away from this short time that we have together a little bit inspired, and maybe thinking about how you can bring visualization into your own development process, with how you write code and how you interact with data. So I offer you this simple formula: more developers plus more collaboration equals more complexity. So there are many more people writing software than ever before, right? GitHub quotes 40 million developers. It was the #1 job in 2019 in the US. And a lot of analysts predict that software developer will be the #1 job across all vertical markets by 2030. So in the next decade. Okay, so lots more humans writing software. But what about open source? What about the way that we write software? Where open source development is pretty much won, right? I don't know what the current stat is, but it's well over 50% of enterprise companies are using some form of open source. So today's software is either using it extensively or built on top of some sort of open source component. So what does that mean for us as humans? Well, it means we're more dependent on code that's written by other humans, and we're also more likely to share code that we've written. So we have this need to collaborate in new and interesting ways. But more humans, more collaboration, more complexity, it makes sense, right? Like, there's two aspects of complexity that I would want to point out. Correctness, so stability, bugginess of our code, it's doing things that we don't expect. And this shows up in sometimes simple ways and bugs that we can find and fix, but sometimes in more harmful ways. You can think of Event Stream or Heartbleed or 737 Max for that, extreme example. But the second area of complexity that hurts us as software developers has to do with speed. So as we take more dependencies on software written by other people, we get the benefit of it because we don't have to write it ourselves, but sometimes there's lots of unknowns in there. And then we have, kind of small projects that we start that turn into very large projects that grow over time. And that can slow us down and really hurt our productivity. So this is something that's really just not going to go away for us as software developers. I love this quote by Nancy Leveson: "We are attempting to build systems that are beyond our ability to intellectually manage." So again, back to the formula: if we as humans, as software developers, don't do something now to improve how we design and develop software, the complexity is going to overwhelm us. And I would argue that it's actually already overwhelming us, in terms of our ability to keep up and of course, like, our ability to ship faster for our users. So I just want to just go back to maybe the very first idea that you had as a software developer, simplest hello world. Like, you have an idea of something you want to create, and that idea guides your creation, right? You tinker with the code, right? You use trial and error. You're trying to, to create and iterate while you do that creation. And all of that creation leads to more change, which means hello world quickly turns into hello churn, right? So we have to keep up with not only our own change in software development, but the change of all the tools that we're dependent upon. And we have to continuously learn that, right? Like, libraries that we use are being updated constantly. So there's this learning churn that we have to go through. And I think this is a it's a big challenge for us. And again, combined with complexity, it makes our jobs difficult. So we don't write software alone. And I think our development should be biased, should favor collaboration, right? Because we're working together on the software that we write. And so I think it's really time for us to move beyond the static text, right? Ways that we can, learn and improve our code as we're in that iterative cycle of creation. And I don't know about you, but, like my brain, like it's finite. I mean, I'm learning, but, and my time, it's finite. And as a software developer, I want to make best use of like both of these very important dimensions that I bring to my work and my creation. So, Don Norman, he is the, father/creator of human-centered design. This quote is, I think, fascinating to me as it relates to software development. So the power of the unaided mind is greatly exaggerated. It's the things that make us smart. So let's break this down. So the mind needs aids, like we need assistance as we're thinking and creating. And what are those aids for us as software developers? Well, they're tools. We write tools all the time to help automate things we don't want to do, to reduce toil, but also to gain insights, to make us, smarter, as he refers to. And that whole process of learning, that's central to that. And I think if you think about the thing that's, most successful, an artifact, a thing, as you call it, it's writing. And that's why we write source code, right, to produce the programs that we use and that are used by the things that we write. And I think this idea of our mind needing help as we create is the case for continuing to have better tools in our software development. Okay, so Melody, Observable, it's a visualization tool. Well, visualization is really a tool for thinking. So if coding is thinking, visualization is a tool that helps us think as we write code. And we need to have this directly in our programming environment. Visualization, it taps into like our visual system, our eyes, like how we understand the information that we're interacting with or viewing in the visualization. But it's really a means to an end. The means is really the insight that we get. And it could be for insight for better decision-making and how we write software, insight to improve our research, our prototyping, our creative process, or research to help us learn, right? To help us internalize what we're interacting with, or to help us teach, right? To explain to someone else what we've learned and what we've created. So enter Observable, right? The magic notebook for exploring data and thinking with code. So first of all, thank you to all of you who are users. If you are here at this meetup and you haven't kicked the tires on Observable yet, we'd love for you to try it and hear your feedback, right? You're working in a notebook, you're able to write code, you're able to interact with data, you get immediate feedback because of the reactivity of the notebook. There's no environment set up. You get access to your favorite libraries. You get to take an example that you find and fork it, make it your own. You also get to share what you know with the world, within your team. And we really believe in the power of that as it relates to improving software development. So enough with the quotes. Now I want to introduce you. I'm gonna refer to them as my friends. There's a lot of data visualization around it's around data, and so I'm gonna try and kind of pique your interest in using visualization to apply it to how you do software development. And you can use data visualization in general as that tool for thinking, but to understand the structure and the flow of your code, right, of the programs that you're either writing or you're dependent upon with the intent to make something better, right? It could be refactoring, it could be maintaining it, it could be, improving it in some way. It could be new features that you want to implement. But it's this whole idea of using visualization for positive change in our own software development. So first up, you're going to meet one of my friends, package dependencies. But it really has to do with how you understand dependency graphs. So I talked about this as really hurting our speed in terms of increasing complexity. So hello, dependency graph. So this was created using GraphViz. It's a subsection of D3's dependency graph. D3 is pretty simple. It doesn't have a lot of, I don't know, very few, if any, external dependencies. This was made in Observable with GraphViz, as I said. You can see how one, on the right, it quickly turns into this, web of dependencies that exist. So, there's lots of things that you can learn by looking at dependency graphs. Say you're making a decision about what library to use. Like, how do you make that decision? Maybe you make it based on, your overall understanding of it. What if you start to think about the dependencies that you're taking with that? How do you decide? How do you make that decision? How do you assess what complexity you're taking on? So dependency graphs can be ways to just learn about, a dependency of a piece of software that you're gonna use, but it can also be about learning about the evolution of your own code with your teammates, of how things are changing and what dependencies you're taking on. So it's a great way to kind of both learn and assess to make better decisions. Okay, hello, meet Sunburst. So say you're trying to understand code, relative file size and directory structure. This is for Flare, which is a data viz library. And you can kind of see here in the visualization the layout of the code and get some sense, like clearly we can visually see that viz is the biggest part of what we would be interacting with. But the relationships between these can start to be really helpful. And if you want to have even more interaction, meet Zoomable Sunburst. So this is actually one of our most forked examples on Observable. But you can actually, let me just drill down and check it out and kind of go down the rabbit hole a bit in terms of interact. Maybe I want to check out, query and understand more about that. But it is a powerful way to visually see and understand the relative sizes. So again, imagine you're at the terminal, right? And you're kind of going back and forth within directories. Just kind of internalize how this can help you as you're trying to understand. Okay, well, say you're trying to understand more about hierarchies and relationships between code. Hello, collapsible tree. So I can actually come in here and sort of just check out and explore in a way that I'm kind of understanding the full hierarchy and explore in kind of in a different way. And if I want to see more about the relationships between kind of the leaves and the nodes and the code, hello, radial tidy tree. So this is another visualization where you can see in a different way the relationships that exist. So, you've seen with the dependency graph and with Sunburst and Zoomable Sunburst, maybe you're looking at the size, relative sizes, and then maybe here with these two, you want to see the hierarchy and the relationships in this way, hopefully leading to a new understanding. What if you want to understand even more about the relationships between the code? So hello, meet hierarchical edge bundling. So I really love this one because it starts to bring in, it shows how you can use color. So say you want to find some hotspots in your code, right? Or you have some hairballs that you want to detangle in your code. There's a real opportunity with visualizations to understand where to take action and begin restructuring code. So this shows, again, relationships in the hierarchy. Each edge is source to target. The blue edges have more outgoing, they have more dependencies, and the red edges have more incoming, right? They're dependent upon. And where you see lots of blue and red, those are very tightly coupled, right? They're critical parts of this code. So you can see that clearly here with data sprite and data makes a lot of sense, right? In terms of the importance of utilizing that part of the code base. You can also see where there's parts that are just, they have local dependencies. So, by being able to explore the code in this way and see the relationships, maybe you're finding surprises, things that you didn't know were there, things that you've learned. Maybe it helps you prioritize where you're going to start, maybe with some refactoring, where there are places where it's fine, you don't need to take action. So there's both a learning and an action that can come out of visualizations that you can use in your own development. Understanding flow, understanding dependencies, understanding the relationships, the hierarchies, the relative size, in a way that, well, maybe I should say it now, which is, I think it's actually fun. I think it is engaging in a way that you can interact and understand at a much deeper level. And maybe through all that exploration, you appreciate the code a little bit more. You understand it more. And I think it is a lot more fun than static text in terms of the experience and what you can learn through visualization. Okay, so if it is fun, I think it's fun, but maybe I'm biased. It also helps you learn, right? I think there's a real intuitive aspect of using visualization. It's not rote learning, it's not memorization, it's exploration. And there's a teaching side of this as well, which is, when you create a visualization, you're teaching yourself about your code. You're interacting with it in a new and interesting way than maybe you would through your editor or through your IDE. And finally, I think using visualization in software development can help us in the work that we do every day. If you're able to observe your code, it can actually help in your productivity. You can use it to prototype and maybe to iterate faster, which means potentially if you iterate faster, you can ship faster, your users get the features that they want, it makes them happy users. There's all this sort of great cycle that can happen through the learning that we do, how it makes us more productive as software developers, and hopefully help set us up to design and write better software. So, finally, I think I wanted to come back to this idea of visualization to help you think. So there's so much creativity in software development. And if we can use visualization as just one of the many other tools in our toolbox when we write our software, it's really helping us, think as we code so we can see it, right? We can learn through interaction, like the example from the zoomable sunburst or some of the trees that we looked at. And if we can help ourselves as humans, as software developers, better understand, we're going to design and develop better software. We're going to do it more efficiently, more effectively, and hopefully we're going to have some fun doing it. It's not easy. It's easy to talk through these examples, but creating a visualization for your own software development, you need to think about what tools you need. I mentioned GraphViz. You saw D3. Vishnu's going to talk in a second about Vega Lite. There's so much out there that you can that can help you. So really kind of think about color, think about the right tools to apply. You can't wave a magic wand to make a good visualization. It really takes time and thought, and definitely consider that as you start to use it in software development. So I don't know if there are any Bret Victor fans at the meetup tonight, but I love this quote. People understand what they can see. If a programmer cannot see what a program is doing, she can't understand it. And this to me is at the core of why visualization is such a great tool to help us in our software development, help us make best use of our brains and the time that we have as we're programming. So with that, I would just encourage you, find those right tools for you to make your software better, to help understand the structure and the flow, the relationships, the hierarchies, even to visualize algorithms that you might be choosing between. Really consider bringing that into your own development. I think there's so much that hasn't been visualized in this space. We're just getting started. And I would really love for us to make visualization a core part of how software development happens in the world, and to do that together.